Okay, so welcome back. Our next and final session of today will be on education. If we are to meet the global challenges, you notice I'm not wearing my glasses. I've realized I can read the fonts without my glasses, so much better than gazing over them like some headmaster. If we are to meet our global challenges, we need to think hard about how we educate the next generation of engineers. Pioneering schools, universities, and charities are starting to re-examine some of the fundamental concepts of engineering education. And our expert panel includes some of the leading figures in this drive for change. Education is a theme that I think cuts across the other topics of this summit. So in recognition of that, the format of this session is slightly different from the previous ones in order to allow more time for a discussion, a Q&A with the audience. And I know we've been sort of squeezed a little bit for the other sessions. So we'll hear a keynote speech followed by very brief introductions by the other panelists, and then we'll launch straight into the discussion. So, our panelists for this session, and I'll, if you don't mind, I'll read them in the order that I have them here, rather than the order they're seated, but I'm sure you can recognize them all. So, first of all, it's very nice that will.i.am has agreed to join us for this session and be involved in the discussion. Then our keynote speaker is Professor John Hennessy, who's president of Stanford University. Professor Damon Dowling, head of the Department of Engineering at the University of Cambridge. Dean Kamen, at the far end there, founder of FIRST, a charity which aims to inspire young people to become science and technology leaders. Robert Matheson, principal of the STEM Early College High School, based at North Carolina State University. And Professor Chris Wise, co-founder of Expedition Engineering and Professor of Civil Engineering Design at University College London. So I would like to invite John Hennessy to come and deliver the keynote speech.
Thank you. Engineers invent the future. They are the ones who will help us find the solution to the global challenges we face around the world. The grand challenge for engineering education is to attract the best and brightest young people to go into this field and then prepare them to make the kind of contributions that we will need to have a sustainable future. But there are a number of challenges. Many students simply don't know what engineers do. There's no exposure in K-12. They learn math, they learn science, but they don't learn much about engineering. And the classical engineering approach, lots of physics, lots of math, and if you survive it, maybe you get to do some real engineering. It turns off too many people. Women and minorities drop out at twice the rate in the US. Modern engineering education needs to be problem and project-based. It needs to be creative. It needs to be collaborative. It needs to be global in outlook to really reflect how the real world works. And it needs to be inspiring. Many students really don't know what engineers do. Engineers used to run trains, but today they do something very different. You turn on TV. You can find out what lawyers do, what doctors do, what police detectives do. You can even find out what politicians do, at least while the press is around. But you can't find out what engineers do. I remember a few years ago I was lecturing to a small class group from a local school that was visiting. And I was trying to inspire them about what engineering could do. So I said, well, how many of you use Yahoo? Well, a lot of the hands went up. I said, you know, Jerry Yang, the guy that started that company, went to this university. They look like this, and finally a hand goes up, and he raises his hand. He goes, did Shaq go here? Shaq is, of course, the American basketball star, getting to will.i.am's key point here. I said, no, but Tiger Woods did. Jonathan Cole, the provost at Columbia, has documented why society is so ignorant of the role of engineers. He surveyed the major history books in use in U.S. high schools and discovered that in the typical history book, there were more pages about hippies, drug culture, and the Beatles than there were about the internet, the telecommunications revolution, or the computing revolution. Engineers are the masters of complexity. This is old-time complexity. Here's new-time complexity. Cell phone. To make this smartphone operate, there are over 10 million lines of code between the base station and the phone itself that have to work. And believe me, how angry do we get when the phone doesn't work? We get very angry. 10 million lines of code that has to work. Teaching engineers about how to master these complex things is a critical educational role for us. Engineering creates better infrastructure. It solves really complicated problems. Take the high-speed train system here in Europe. The trains are moving so fast that an engineer cannot see a hazard where a train has stalled in time to stop the train. It is physically impossible to stop that train in time. Only through a complex set of electronic signals of software that has to work for that train to move forward can things really work. Look at the tunnel. I think if you told people 30 years ago you were going to build a tunnel under the English Channel and it would work reliably, people wouldn't believe it. You've got to make it work, you've got to prevent accidents, and you've got to change the world with this kinds of thing. Of course, infrastructure is part of what has made our lives better, and engineers are the ones that create complex infrastructure. But engineers also work on sustainable problems, and I think we heard earlier the importance of trying to teach sustainability and get the sustainability gene injected in young people. Well, it's absolutely crucial in engineers. And here I agree with what Jeffrey Sachs said. Of all our sustainability challenges, energy is front and center. If we don't solve the energy problem, the other ones won't matter that much because our planet will be in deep doo-doo. That's a technical term, of course. So what are engineers doing? They're bringing new creative solutions to it. Techniques using nanofibers and nanowires to try to dramatically increase the battery density. Imagine a factor of 10 leap forward in energy density. We'll all be driving electric cars. We could all drive electric cars, not just those that can afford Teslas that cost $75,000. All of us could drive electric cars. Or imagine if we could get a real breakthrough in thin-film solar technologies so that solar cells would be much easier to install and much easier, much cheaper. That would, again, change our world. Engineers work on these kinds of problems. Getting students involved in these kinds of problems early will inspire them about what engineering can do and get them thinking in a sustainable fashion. Engineers collaborate. They collaborate a lot with doctors. Doctors don't invent all these technologies. Engineers collaborate with them. Of course, one of the greatest innovations in terms of reducing healthcare costs and improving outcomes is the balloon catheter, a collaboration, fundamental collaboration between engineers and physicians. In the other picture, you see an emerging collaboration, using the ability to read brain waves to help a patient who's been paralyzed. This young woman was able to control a robotic arm to get a drink of water, something she hasn't been able to do for herself for 10 years. And what's fascinating about this is it's deep engineering. Unlike a system where the individual has to train the robotic arm and learn how to train something different, in this system, the brain waves are actually interpreted in their natural state. So thinking about moving your arm moves the robotic arm. It's deep signal processing and deep analysis of how the brain is working that leads to this kind of thing. Collaboration is a critical ingredient, and it's critical that we teach it to our young engineers. Engineers improve the quality of life. They innovate. And getting that innovation gene deeply established in young people is critical to their success as emerging engineers. Whether it's tablets and cell phones, or Stanley, the self-driving car. Stanley was really a breakthrough. In the previous years, the DARPA Grand Challenge, the longest ride in the car had been able to go no more than 7 miles, and that was on standard roads. In the DARPA Grand Challenge that Stanley won, the car drove 133 miles on a combination of conventional roads and desert roads that were not paved. It finished the race by going up something called Beer Barrel Pass, a climb of about 200 feet with sinuous curves on it and no guardrails. I wouldn't have driven on the road, but Stanley did. Stanley fused together lots of different innovations, new sensing technologies, multiple approaches to finding out where the road is, and clever use of machine learning. And this is where the kind of innovation really comes in. One of the most difficult things for an automobile to do is driving down the road and it sees a dark patch on the road. Now it has to figure out whether that dark patch is actually a big hole in the road that it has to avoid, or simply the shadow of a tree that's cast across the road. Easy problem for people, difficult problem for a car interpreting those signals. But that's the kind of innovation that we need as we move forward. Many students don't know who engineers are. I look at this picture. This is an old IBM advertisement, but I love it. If I go down to Silicon Valley and I compare this picture, in this picture, these engineers are 2 male, 2 white, there are too many ties, and they use obsolete computing equipment. It's important that engineers see themselves as doing cool work. The coolness factor is a critical ingredient in getting young people into engineering and exciting them about their education. If young people don't see other people in the field that look like they do, they have a hard time sticking it out. Engineering is a tough discipline. It's not easy. It's challenging material to master. Figuring out how we do a better job of that is absolutely crucial. One way to do it is to make it more people-oriented, to get engineers working on problems that they see changing people's lives. That certainly inspires people who want to make a difference in the world and who want to see their career as oriented towards helping people. It's also critical to build teamwork skills. Computer science is a discipline that has an interesting story to tell in the United States. Early on as a discipline, there were actually a reasonable number of women in the discipline. Then, in the 1980s and 90s, as the discipline grew by leaps and bounds, it attracted far more males than it did females. And today, it has a dramatic imbalance. Of course, things like video games and a video game culture contribute to that imbalance. But we have to think about how we turn that image around so that we're attracting the best and the brightest young people, wherever they come from. Many students simply don't know how engineers work today. They have this image of sitting in a cubicle. In fact, I was teaching a course a few years ago, and I had a number of young women who were considering going into computer science in the course. And they said to me, well, the problem is that guys would sit with a bag over their head and their terminal and their computer in there, and you just have to slip food under the bag and they program all the time. And this young woman said to me, I don't want to do that. So what did I do? I took her down to Google. That image you see on the left is from Google. That's the way Google works. There are no 2-person offices. They're mostly offices of 8 to 10 people. There's lots of common space. There's lots of interaction. There's lots of collaboration. Big engineering problems are not solved by lone wolf approaches anymore. They're solved by collaboration and team building. Some students see engineering education looks like this. The only difference between this and a modern classroom is if you took a modern classroom, you might have a little more gender and ethnic diversity, and you'd also have all the laptops open. But if you went in the back of that large lecture hall and looked at those laptops, you'd see Facebook rather than class notes was running on them. We've got to do a better job of educating our students differently. We've got to integrate them in different approaches. And we've got to help them think about the importance of science and mathematics as underlying disciplines for engineering. But we've got to put some design first. We've got to put problem solving at the center of it. Engineering education then has to be project-based, collaborative, and multidisciplinary. But of course, we also have a wonderful new thing that's happened with the online revolution. It was only 18 months ago that 3 Stanford faculty decided on a lark to take their courses, put them online, and make them available to the entire world. In 18 months, MOOCs have become a major phenomenon. But we've also, while we're very much in the experimental time and we don't understand a lot of things about MOOCs, one of the things we really do understand is that they're going to change the world. And I think they're going to do that in 3 ways. They're going to help us educate the rest of the world. And I'm afraid, since Lady Gaga's songs sell for 99 cents, Jeffrey Sachs's lectures are not going to sell for 99 cents. He's a nice guy, has important things to say, but he's not Lady Gaga or Will.i.am, so it's going to be free. Secondly, we are going to have to figure out how to bend the cost curve. While access to education, high-quality education, is a big problem in the developing world, in the developed world, cost of education and its effectiveness are the big problems. We have to find a way to help improve productivity without decreasing the cost of the educational quality. And that's our challenge. How can we use these kinds of technologies to improve educational quality? Well, we can. We can make them more interactive. We can make them adaptive. We can do more self-pacing so that students with different skill levels can move through course material in different ways. And of course, we can deliver it any place, any time. Engineering education should be inspirational and should be available to the entire world. Thank you. Thank you for joining us here this afternoon.